All right, everybody, we're going to get started. If you want to take your seats. My name is Brianna, and I'm the events coordinator for Ice House on Main and Grand Stafford Theater for the private events. And I'm going to read you some sponsors and then introduce our speaker. So for our sponsors tonight, we've got Capture Technology, we've got Improving, it's what we do. We've got Texas A&M Cybersecurity Center, Innovation Underground, Electronic Systems Engineering Technology. We've got T-Star, ISSA, HTRI, and of course the Grand Stafford Theater. So if you would help me welcome to the stage, we've got Madeline Tesch tonight to give us a wonderful talk about nuclear aviation.
Hi guys, I'm Madeline Tesch. Originally I was born in Arizona, so sorry, I'm not a Texan native, but I've been at Texas A&M for about 1.5 years now, and I'm here to tell you about the project that I did with Aggies Create. So this is the Nuclear Aviation Project, and that sounds very ambiguous, so let me give you some context. We are basically a project that was put together by Aggies Create to participate in a NASA competition called the NASA Gateway to Blue Skies Project. And last year, the competition was about finding a way to integrate green energy into just the entire aviation industry by 2050. So essentially, NASA asked us to put together a general proposal that would tell them exactly what we wanted to do, how we wanted to do it, and when we wanted it done. So our plane, actually, we ended up proposing a nuclear plane. I know, sounds scary. Stay with me. What we did was we put a nuclear reactor inside the belly of the plane, and then we used that nuclear reactor to power its engines. And yes, still scary, I know. But I promise you, half of our report was about safety measures. So what we did was we took the nuclear reactor and we put the safety measures around it. We put a lot of insulation, we put a lot of lead, we put all the rest of it in, made sure that it was protected from people, and then we used the heat and the transfer of heat energy to fuel our engines, basically. And most of what we did actually happened to apparently please NASA, because they came back to us and said, can you please put together a paper and come present for us at Forum? And this is what I'm going to tell you about. This is what we talked about in our paper. So naturally our proposal was over the integration of the nuclear reactor into the plane by 2050. So why did we choose nuclear? One of the main drivers for why we chose nuclear was that it had zero carbon footprint, which was really, really great for us because it meant that we didn't have to combat anything in our production cycle. It meant that our reactor was completely clean, install it, let it go, it runs, right? We also liked that it was fairly cheap once you got down to it. We didn't end up using uranium in our early stages. We ended up using a different kind of nuclear material, which would allow us to mine it cheaply, manufacture it cheaply, put it in a nuclear reactor, right? So mostly we liked it because of the shock factor. I'm not gonna lie, we told Launch about this in the meeting and he went, absolutely not, we will not be doing nuclear, that's a terrible idea. We did it anyway, sorry Launch. So what was our reactor about? Our reactor was mainly circular, and it would have HALEU non-weapons grade uranium inside of it. We ended up bouncing back later because we found out that the material that we wanted to use would not have been as heat efficient as we needed it to, so we're using HALEU non-weapons grade uranium, along with all of these other fantastic metals, lithium 7 hydride. And essentially what they would all do is you would heat the metal inside of the reactor, and then the heat would be transferred to pipes through a non-connected heat transfer. These pipes would then move to our engines in this diagram here, and the engines would heat up and produce thrust. It's honestly not as complicated as it looked. I know looking at these diagrams makes you kind of want to throw your head in. It's okay, it's okay. So once we had our reactor down, we decided to look at our plane, and what ended up being the best plane for us was the Boeing 737. It's very commercial, it transports people across the US, and it was very easy to get numbers for it because of Boeing's lovely website. So we integrated all of that inside, and we found out that mainly the biggest problems that we had were that the plane would be very heavy and it would be very hard to produce. So a lot of our paper focused on safety, production, and how to get the people to accept the plane, because I know none of you want to get onto a nuclear airplane.
I'll sign up.
Well, then you guys are definitely in the minority of the population. So this is our reactor system. That at the top you got the reactor. We ended up creating a more official diagram for NASA, but this is one of our old PowerPoints, so it's still got our hand-drawn one. I think it adds character.
Yes.
Yeah, so it'll heat transfer through the pipes, and then it'll come out to the engines. And for the engines, we ended up using air compressing engines instead of fuel combustion engines. So the air comes in, goes out. The biggest problem we had with that was, again, our plane was going to be very heavy, so we ended up having to add more engines than we usually would. So this is our team. They'd love to be here tonight, but a lot of them had class, so you get me. I hope that's okay. So that's me, Kai, Claire, Arnold, Brennan. We all went and we told NASA that we want to create a nuclear plane. So I think all of us are actually just a little bit insane, but that's okay. So we put together a paper. It was a lot of research, but it was a ton of fun. And we presented it to NASA, and we also presented them with this poster here. This is our poster. It essentially is all of our project condensed down into just a couple of photos. And to take you through it from start to finish, you start with mining. The mining plant was mainly based around how would we get uranium, how would it work, what's the best way to transport it from one place to another. And we found out that there's actually a lot of environmental concerns surrounding mining uranium right now, because the Colorado Plateau, which is our largest source of uranium, is currently in Native American territory, and those Native Americans are working with the US to establish better safety conditions, and until those safety conditions are established and agreed upon, they've halted all mining. But eventually, we believe that those safety regulations will be, solved, and we'll be able to mine uranium there again. And once it's mined and milled, which is actually where the most of our environmental measures would need to be placed, because mining and milling, it's terrible for the environment. You take, radioactive sludge, put it through water, and gotta keep that clear, right? So we ended up coming up with ways to do that by just planting a lot of vegetation in the area and making sure that we had good practices for the disposal of the uranium sludge. Next would be one of our enrichment facilities. We said that this would be somewhere in Nevada situation, so it would go from Colorado to Nevada, get enriched, and then get put into a plane. The enrichment facility itself is really something that we would have to develop in the US, because we don't have a lot of nuclear enrichment sites in Nevada right now, believe it or not. So there's that. And then it would go inside of our plane. This would be our plane structure. You can see it has 2 more engines than the regular Boeing 737 does. This again is because we're using air compressing engines, which will create less thrust, which would require more of them. Mostly we would put it where the baggage claim would be, so the reactor would sit underneath the plane, and we would move our baggage claim to the front and back of the planes. So that's how that would work. Don't worry, your charges would not increase for baggage. Yeah, and you can see our way more official diagram down in the center there. I know it's a bit small. And then we talked about a lot of the finances that would go with this. So it's very expensive to produce a plane. Trust me, it is. It's even more expensive to produce a nuclear plane. But we found out that by cutting fuel costs, we can actually eliminate millions of dollars from the cost to manufacture and fly a plane, because nuclear planes don't require fuel at all. So while it would be most effective for longer flights that require more fuel, you're still saving a ton of fuel in landing and takeoff, which actually is where most of the fuel for your flight comes from. So every single plane would benefit from having a nuclear reactor in it. Let's see. Storage of the planes. So the nuclear reactor itself, you would run almost continuously unless it needed to be changed or stored. In the event that you needed to store it for a long period of time, we would take out the uranium capsule inside of the reactor and store that somewhere else, which would make it easily storable. It goes in a warehouse, you leave it, you come back to it, it's still there. And lastly would be recycling and disposing of our uranium. So we have a couple of recycling plants in the US, but not very many, so we need to develop that eventually before 2050, before this can be implemented. But recycling of the uranium itself is very doable. We've got new laser technology that we've been researching, which makes it very cheap, efficient, easy. And then we figured that we just, bury the radioactive stuff underneath the mountain. Yeah, no. We would be recycling most of it. So a good 80% of it would go back in and be reused again in other reactors. But the rest of it, that 20% that we just simply cannot recycle, it's done, it's gone, would end up underneath the mountain and would eventually decompose. So overall, we end up with a fairly carbon neutral timeline for events. And this is our little timeline down in the corner. I know it's practically impossible to read, but basically, so long as you're using policy decisions within that time, you could very much have laws enacted and different policies for people and public information that would make this possible by 2050. And this is what we presented to NASA. They said that they loved our concept, but thought it was like way out there. They thought we were insane. I'm not gonna lie to you. But we had a ton of fun presenting it, and I think we really got like 3 out of the 8 judges to consider it, so I think it went well. If you have any questions, I'd love to answer them. Yeah?
So how much weight does this add to the 737?
Quite a bit. I think it was somewhere like 1.2 tons when we did the calculation, so
that's
it's
not bad.
quite a bit.
No, but that's not bad.
It's not terrible.
And that includes like, you get all the shielding and everything you need if it crashes and all that.
Yeah.
So we're
Okay.
using a small modular reactor, which essentially means that we take the regular reactor size, shrink it into a sphere, and then shrink it as far down as we could possibly get it, so that really decreased our movement a ton.
And what's the time between refueling, like for a typical 737, like how many years?
We estimated about 5 to 7 years, depending on how big your plane was and how much we're using the reactor in it.
How's the reactor cooled?
The reactor is cooled using lithium-7 hydride. I know that was back there. Let's hold this here.
Not that I know what that is, but I remember it on the slide.
Yeah, so most of it would be heat exchanger, right? But the reactor itself, the heat exchanger would kind of stabilize the reactor. Lithium-7 hydride would be used, and we'd have safety pins in it. But for the most part, we don't super want it cool, because all of that heat is what's going to go to our engines to make the thrust happen. So for the most part, it can be cool, but it would take some time.
So the type of engines you're describing work great at high speed, but they work really bad at low speed. So is there any consideration on how to overcome that for like takeoff or landing?
We did talk about maybe including a battery in our plane if that were the case, but for the most part we expect that by 2050 we'll have a better handle on these engines, especially if we're pushing to put them in most of our commercial planes, and that a lot of the problems to do with takeoff and landing would be solved by that time.
Was there any consideration to making the engines hybrid?
We thought about it, but for the most part we ran into a lot of laws that just prohibited that from happening, especially overpopulated areas. Yeah, sound laws are terrible.
So, did you consider all the time savings, if any, of not having to refuel conventional, jet fuel, if you will, and also I'm guessing that this particular engine will require less maintenance than a conventional internal combustion engine.
So this engine in particular, if we were to take this to market, would have a lot of safety briefings around it. So after every takeoff and landing, it would be inspected. So we don't really save a ton of time not refueling because you have to check the reactor, make sure the reactor's okay. But I mean, I suppose there's some time. We didn't include that in our report because it wasn't necessarily what NASA wanted us to talk about. But as far as like time savings, I think it would be about the same.
And then what was your second question? I'm sorry, I forgot it.
Maintenance issues, but you're saying that.
Otherwise, for safety stuff, we also have a set safety plan. So every 7 years, the reactor would need to be like taken apart and really inspected. And then for every year after the first 7 years, it would have a routine inspection because that is when the reactors tend to start breaking down.
So 7 years, let's say we gotta replace the reactor, is that like, you might as well just buy the plane, or how is that?
At that point, it really would be easier just to replace the reactor because the shell of the plane and all of the parts in the plane would still be working. And for the most part, because of the frequent inspections that the reactor goes
But I mean, is the
through,
reactor like 95% of the cost of the plane, or is it like 20%? Yeah.
if I remember correctly, it was around 60 or 70%.
Okay.
So it is expensive, but if you're inspecting a reactor
It's still
and
worth it to
something's
keep the
wrong,
rest of the plane and replace the reactor. Okay.
yeah. If something is wrong, you usually only have to replace one or two parts in the reactor. The only reason that you would need to replace the whole plane is if maybe your like heating piping system was terrible. Because if that were to happen, then that would compromise your engines too, and you would just need to buy a new plane.
How did you guys go about getting the background information for your proposal?
That was a challenge. One of the best things that we used was all of our lovely professors at Texas A&M took a lot of time to come and talk to us about it. We had a group of 9 or 10 undergrad students and one graduate professor leading them that invited us to their meetings to learn about how a nuclear reactor works, what a small modular reactor would entail. We had 2 undergrad students from that same group who came to our meetings and started talking to us about what our safety considerations would look like and how large our shielding would be and how much weight that would add to the plane and stuff like that. So a lot of it was reaching out to people, but we also had a lot of help from just Evans Library in general. We have a very extensive just backlog of a ton of research. So it was a lot of reading and a lot of talking to most people, but we got a ton of help from our professors. And especially our advisor at the time.
Did you do any like calculations that said, okay, it takes this much energy to power a plane? Did you do, it takes a similar amount of energy to charge batteries?
Yeah, we did. We eventually, at first, we were thinking of putting a battery in the plane for takeoff and landing, and so we did the energy calculations for that, and we found out that a lithium battery would weigh more than the reactor in order to take off and land the plane, which is why we eventually scrapped that idea. I wish I could give you the real numbers, but again, this was 3 months ago. If I could still remember them, I wouldn't be an engineer, I'd be a millionaire.
And you said having a hybrid with like, say, a couple of turboprops to help with takeoff and landing is not legal?
The reason that we scrapped the hybrid idea was mostly because of the weight of the batteries. We were not
I mean like just powered by jet fuel.
Oh, powered by jet fuel. The reason we didn't want to do that was mostly because it would decrease our carbon, like it would increase our carbon emissions, and we really wanted to present to NASA like a carbon neutral solution.
Gotcha.
But absolutely, a hybrid plane would probably be really, really great. It was just outside the scope of our project.
Can you give us, if you know, a comparable of how much energy is going into flight in comparison to providing power to infrastructure in an airport? The reason I'm asking this is because, like right now, if you buy a car, an electric car, and you're not using it, and then you lose power in your house, you can actually plug it in and it reverses. It feeds the house. And in this case, from what I understand, from what you mentioned, the engines, the reactor is working all the time. So energy is being wasted if it's not used, right? Am I wrong or?
No, you're right. So when our planes are landed on the ground, the reactor would be running itself. We personally did not do calculations to see how much power that would provide to the airport, but I can tell you that the airport itself could be powered by a hydrogen reactor if that was needed, because earlier in our project designs, we presented NASA 2 ideas. We presented them this idea as well as an underground hydrogen reactor, so a reactor that would just create hydrogen gas to fuel the airport. I'd have to say, I don't think that even if you had a fleet of planes here, because the plane takes so much less energy than the airport itself, I don't think that you could fuel a whole airport based on just using the planes. But I think that they could probably do conservatively 35-40% of the airport if you had maybe 20-30 of them.
Depending on the size of the airport.
Yeah, depending on the size of the airport, of course. Yeah.
This is when you're a good partner.
So you can do like Easterwood Airport with half an airplane.
Oh no, I've flown into some airports and I'm like, I think I could fuel this with a candlestick, actually. We could just place it in the center and light up the whole thing. So if there are any more questions, otherwise I think that's my whole presentation. Thank you so much.
Thank you.